Hello everyone, and welcome back to another cartography lecture video. And in this lecture video I want to continue our discussion on classification schemes by moving on to the next type of classification scheme, which is going to be quantile. So to recap where we left off before, we had talked about this idea of classifications as breaking data down into meaningful groups, and there was this idea of breakpoints and then this idea of classes. And the whole point of classification schemes was to figure out where to place these breakpoints. And we talked about this idea of equal interval, which was the idea that we put these breakpoints so that the distance or the number or the range between each breakpoint was the same, hence equal interval. And we did that by taking the entire range, so the maximum minus the minimum of the data, and then dividing that by the number of classes we wanted. And we did that so that we would end up with the same range for each class. So what I want to do now is I want to talk about a different approach called quantile. Quantile. Right? And so quantile, you might recognize this or think of quartile, and it's actually because they do come from very similar, the approach is very similar to what we did when we were talking about quartiles. And so the idea with the quantile is that it breaks the data up so that each class or group has the same number of observations or as close to it as possible. So with quantile, right, each group, or again, you could think of this as class, has the same number or as close as possible of observations in each group. So if we think back to equal interval, right? Equal interval was designed so that each group had the same range. Quantile is designed so that each group has the same number of observations or as close as possible. And we'll talk about why that as close as possible typically comes into play. So the way we calculate the breakpoints for quantile is going to be to take n divided by the number of classes. Right, and again, in this case, this n is the same thing we've always been using n to designate, and that's the number of observations. Right, so this is basically going to be the number of observations divided by the number of classes, and then once you have the number of observations in each class, which is what this will give you, you simply just start at the beginning and you count your way down the list. So if, for example, each class had 3 observations, you'd start at number 1. The first 3 observations would be in one class, the second 3 would be in the next class, and so on and so forth. So hopefully we can see from this equation here one potential issue or one reason why this as close as possible is going to come into play, and that's what happens when you have fractions of observations. Right, let's say that we had 5 classes or 5 observations and we wanted to put 2 classes, right? If you do the division on that, you get 2.5 observations per class, right? 2.5 observations per class. Well, obviously, right, it doesn't make sense to have a half an observation, right? You can't do that. You can't split an observation in half. So what you would end up with, or what most of the time you would do, is you would try to balance that out by having one class of 2 and one class of 4, right? So C1 would have 2 observations, C2 would have 4, because you can't have a half an observation. So that's one instance where this as close as possible comes into play. The other instance where as close as possible comes into play, and this is really important regardless of what method you're using, is you never split the same value into different classes. right? No matter what you do, you never split the same value into different classes. So if you have 3 records that all have a value of 7, those 3 records should always go in the same class. And with quantiles, right, you could imagine where the class break would fall. Maybe it would be in the middle. So let's go ahead and say we had 5 observations of, let's say 3. Let's say we had 6 observations. 3, 3, 3, 4, 6, 7, 9, right? And we wanted to make 3 classes. So normally we would take the number of observations here, which would have been 1, 2, 3, 4, 5, 6, 7. Actually, remove the 9. Let's do 6. We have 6. We want to do 6 observations into 3 classes. That would be 2 observations per class, right? So if we were to do this just normally, we would start here, 1, 2, breakpoint, 1, 2, breakpoint, right? That's the way we would normally do this. But if you look here, we divided this 3 from this 3. You can't do that. That is wrong. Instead, what you would have to do, let me erase that and we'll start over because that's bad, right? You do not want to do that. So let's go ahead and delete that. And let's start over here. Let's do 3, 3, 3, 4, 6, 7. Right? Instead, what you would have to do is you'd say 3, 3. So you would normally want to put a break here, but you check to see this is 3, so you can't. So you'd put the break here instead, and here. Right? So in this case, right, we would have a class of 3, a class of 2, and a class of 1. Right? So even though the idea with quantiles is you want the same number of observations in each class, there are going to be certain cases where that's not quite going to be true. When you have half observations because the numbers aren't divisible properly, or where you have the same value occurring multiple times, you do not and cannot and should not split it. So hopefully that makes sense. Let's go ahead and just quickly look at an example of this in practice. So here we have the same data set from before. I just cleaned the Excel sheet up a little bit. And we're going to work with the classes again. So what we're going to do, we've ordered the data set already, just like before. And I want to do the same thing. I want to keep that 3 class scheme going here. So let's go ahead and do the same scheme here. So if we have 11 observations equals 11 observations, and then we want 3 classes, right? Because that's how we calculate the number of observations, is the total number of observations divided by the number of classes. So 11 divided by 3. So again, we have 3.66, which means we're going to alternate between 3 and 4. So what we're going to do is we're going to start at the top, and we're going to go 1, 2, 3. So these first 3 observations are going to be class 1. Then we're going to go 1, 2, 3, 4. These 4 observations are going to be class 2. And then we're going to go 1, 2, 3, 4. And these 4 observations are going to be class 3. So you can already see here how we've already made a pretty drastic difference. And then what we would do is we would say class 1 goes from 4.3 to 4.5. Class 2 goes from 5.1 to 6. And then class 3 goes from 6 to 6.8. Right? So you can already see how we've made a pretty drastic difference in the classes. So that's how you do quantile. Number of observations divided by the number of classes, and then you just simply count down the line, making sure that you actually don't make a mistake like we did right here, where this actually is not correct. So what I would probably do in this case, I actually just caught this, right? I would actually change this. I would make this into class 1, and then I would make this into class 2. Right? And the reason I did that was because, again, we don't want to separate these 2 6s into different classes. And you can see that we still have roughly the same number of observations, right? 4 4, and 3. And then this would be 6.2 to 6.8. And this would be 5.1. And then this would be 5.5. So hopefully that made sense. Hopefully you see why I went back and did that change, because again, you do not want to split values. If you have any questions, as always, please reach out. Thank you.